All right, so number one. Keyword here, what is the most precise definition of a segment bisector? Uh-oh. When I read segment bisector, we know the difference between a segment and a line. So a segment does not go on forever. It's from one point to another. And then bisector, that is something that cuts a section into two parts. Okay, so A could be correct, but I don't know if it's the most precise. B, a segment that is cut by another line segment into two equal parts. That could also be correct. C, a line segment that cuts another line segment into two equal parts and creates two equal segments from the midpoints to the endpoints. That also could be correct, but maybe a little too much. And then D, a line, ray, line segment, or a plane that cuts a line segment into two equal parts. So I'm going to tell you on the test, they're not going to be this precise. The correct answer is B. Number one is B. How many of you also got B? Good. And if you're watching this at home, I would go through and do 1 through 5, write down what you think the answer is, and then play the video. Again, what is the most precise definition? There could be more than one of these that could work, but which one is more precise? Midpoint. When I read that as the middle point. Middle point of what? A segment. So we have to make sure they're not talking about lines or rays, segments. A point in the middle. Maybe. Probably not precise enough. The point that divides a segment into two congruent segments. Congruent just means equal in geometry. That could also be good. The point that creates two segments equal to each other and congruent to each other. Equal and congruent mean the same thing, right? Well, technically congruent is the word you should use. The point must also be equal distant from the endpoint. So that one's a little bit too much. And then D, the bisector of the segment. That is not correct. So I would also go with B on this one. Define collinear points. I see the word line. Co means same. So I think of points that are on the same line when I read that. A, points on the same line. That's exactly what I just said. Together on a line, probably not precise enough. Why? Because what is on the same line? People, houses, what? Right? Points. Points that are together on a line and that make an infinite set of points on the same line? Not necessarily. Or points that lie on the same plane, that's coplanar. So I would go with A on this one. Define line segment. A definite set of points. A portion of a line that consists of a defined beginning and all endpoints and endpoint and all points in between. That could be it. A set of coplanar points. That's too generic. The distance between 2 points. That's not correct. So here I would say 4 is B. A precise definition of a perpendicular bisector. Perpendicular means 90 degrees. Bisector, what did that mean? Well, we talked about it, right? Bisector, cuts it in half, is the short answer, but the more precise answer was B, right? So the short answer is 90 degree cut in half. And notice it says a line, ray, or a line segment that cuts a segment into two equal parts at 90 degrees. That's true. An intersection of a line segment that forms a right angle. Not quite. Cutting a segment in half that creates two equal parts and makes a right angle. The equal parts are also congruent, a little bit too much. and a bisector that is perpendicular. Well, that just used the word as in a sentence. So I would go with A. All right. So what I would say now is that you go through and try 6 and 7. So if you're watching at home, I'd pause the video and try 6 and 7. So on number 6, I have this diagram. I'm supposed to use, 1 second, you can't see what I'm writing. I'm supposed to use, did I say notation? If I can. There's not notation for every single thing, so we might have to use some words. But I need to say a few things. One, I need to make sure the person knows that these are not lines, that they're segments. So I need to tell the person, one, that AC is a segment. It is not a line. I also need to tell the person that DB is a segment. Okay? That means they don't have arrows. They're not lines. They don't go forever. And then what I could put in the middle to show that those two segments cross at 90 degrees is this symbol. So this says that AC and DB intersect at 90 degrees. Or I could write that out in words. Same thing. Okay? So I just told the person these are segments and that, 90 degrees. Now I also need to tell them that these are congruent. So I need to say that DE is the same as EB. You see that? That's what that little hash mark means. It means that they are the same. And then I might also even add, and this might be too much information, I might say that A and C, AC and DB intersect at E. And I'm going to call it point E. Pointy. It's very pointy. You could have also said, using the word perpendicular bisector, if you use words, you could say that AC and DB are perpendicular, or AC is a perpendicular bisector of DB. If you use words. Perpendicular bisector means it cuts something in half at 90 degrees. Number 7, I need to make sure the person knows that all of these are lines. So there's not 90 degrees. So I might just say that TR or RT. So by putting this line symbol that says that TR is a line, and I'm going to say TR, and I don't think there is notation for intersect that I can remember, but I would say that TR intersects QU. And I might be wrong, there might be a geometry notation that could go there, but I've never used it ever, so I'm just going to put the word there. TR intersects line SU at point S. Pretty sure. And you know what? This would make more sense if I called it line QU. Just notice that. I should call it QU. Technically I was still correct, but it just it'll be easier to draw if I call it from one point to the other and I use all the points. Otherwise, I wouldn't know that point Q even existed. So TR intersects QU at this point. Done. So on number 8, and again, I don't want to focus in on too much. This is about being precise. Again, we didn't spend much time in this class being precise. But Mr. Hargens thinks the definition for parallel lines are two lines that never intersect and do not share common points. Is that good? Yes. Okay. Mr. Hargens thinks that a ray starts at a part of a line, starts at an initial point, and then goes on forever in one direction, while not going on forever in the other direction. That is a ray, right? That works for me. Okay. Let's get into the more, what I think is mostly on the test. Let's go through and fill in the empty boxes. So sometimes I give you the words. Line FA is perpendicular bisecting segment GD at point S. Try to write the notation, try to draw me a picture. Here I have the notation, try to draw me a picture, try to put it in words, and so on. So let's try filling in the empty boxes yourself. So if you're watching at home, pause the video, and we'll go over it here in a second. So again, just ignore this. I didn't want to rewrite the whole chart, but line FA is perpendicularly bisecting segment GD at point S. Well, line FA, I could put line FA is like this. That means line FA. Perpendicular bisecting, so I'll use perpendicular symbol. What is it perpendicularly bisecting? GD, which is a segment. So I need to put GD as segment notation. I'm going to start using different colors so it stands out. So all I've said so far is you have a line that makes 90-degree angle with the segment GD. Okay. Now, I am more, for me anyway, I have to have a picture. It helps me describe things better. This is not done, but I'm going to go ahead and try to draw me a picture. So if I'm drawing a line FA, so I'm going to have FA. I'm going to put F here, A there. And again, it could be backwards A and F. We don't know. Perpendicular bisecting GD at point S. So I need to draw GD. And it's a segment, so it doesn't go forever. So I would not put arrows on that. And it says line FA makes 90 degrees, so I'll put 90 degrees there, and bisects it. So you can't bisect a line because lines go on forever. There's no way to cut a line in half. So you have to cut a segment in half. So I could say that these are equal by using that notation. That notation will say that where do they bisect point S? Right there. So I believe I drew the whole picture. Line FA cuts GD in half at a 90-degree angle, and where they intersect is at point S. Okay. So far, all I put down was that they're 90 degrees. I should also put that segment GS is congruent to SD. Okay. And then I might even put in words that they intersect at point S. Right? That one was probably kind of hard. All right, here, this says that we have the segment CA that is congruent to segment CT. So I'll put segment CA is congruent to segment CT. I know those are segments because, and I forgot, I should have put, what was over this? Was it, hopefully, was it a segment too? It was? I forgot to put that on there. You can't assume. Okay. Now, in here, this is not a line, it's a ray. So I'd say array AR is perpendicular to segment CA. Okay. And now I'm trying to draw this in a picture. So I'll probably start with array. So array starts at A and it goes off in one direction forever. We can put R anywhere we want, right? That's what array looks like. Now this has to be the end point. This is the direction it goes off forever. And it's perpendicular to CA, which is segment. We're not going to have two A's, so what that tells me, CA would be like this. And I would say that these are 90 degrees. So far, ray AR is perpendicular to the segment CA. Those are the same A, so that's why they intersect there. And then I also need to say that CA is congruent to CT. Well, here's CA. I'm going to guess that CT, to be congruent, it's not going to go that way. It's going to go this way. Now it doesn't have. It could just do this. There's many different ways. I could make this T, or I could have just continued it, or I could have drew it this way or that way. There's more than one answer that it could look like. But to say that they're congruent, to say that CA and CT are congruent, I'm going to put this symbol there. This one, all this says is that segment AB is congruent to segment CD. Segment AB is congruent to segment CD. Done. That one was easy. How do I draw that? Well, I would draw AB. I would draw CD somewhere. They don't even have to be, it could just be this. Figure not drawing the scale. And then to say that they're congruent, I could just do that. Done. Again, there's many different pictures it could be. Finally, and I did a terrible job at this drawing, but there were two triangles here and two triangles here. And I believe that these were segments, right? So to say that they're segments, I would say JK. And this means parallel. The triangles mean that they're parallel. So for parallel, I'd use this notation. Two lines up and down. JK is parallel to LM. And they're both segments. That's just a fancy way of saying these two segments are parallel. And I could say segment JK is parallel to segment LM. And I'm done with that. All right, next. We're given XZ is 50, XY is 2X, YZ is 8X plus 10. We're given that X, Y, and Z are all on the same line, collinear. And we also know that Y is between X and Z. Draw a picture, solve for X, then find XY. And I kind of wrote an abbreviation, which if I was to turn my work in, I would probably write it out like this. So they said you have X and Z. Draw a picture. So I'm going to call this X and this Z. I know that X, and I also know that Y is between X and Z. Now where should I put it? It doesn't matter. I'll put it here. Just somewhere between. Okay. I also know that XY from here to here is 2X. And I know that YZ from here to here is 8X plus 10. And furthermore, I know that the whole thing from X to Z, and I'll just draw it down there, the whole thing is 50. So I have basically two segments to add up to 50. So I can do that and say, okay, this segment plus this segment will be the whole thing, which is 50. So I'll say 2X plus 8X plus 10 equals what? 50. From there, hope you were paying attention in Algebra 1. I would go 2X plus 8X is 10X. And if you need help with these smaller skills, please let me know after. And then from there, I would take away 10. $50 minus 10 is 40. Divide by 10. And I get X is 40 divided by 10, 4. That is only half the answer. They said, what is X? They said, solve for X. They also said, find XY. So I have X is 4. They want me to also find XY, which is just 2 times X. Well, 2 times X is 4. So I could say that this is 8. I could say that XY equals 8. And I also know that X is 4. Now, if I wanted to check my work, and this is almost too large, I could plug 4 in here. 8 times 4, 8, 16, 24, 32. 32 plus 10, 42. Is 42 plus 8, 50? Yes. So I know without a doubt I am correct. Okay, on this problem, number 12, we have A, B, and C that are collinear. That means they're all on the same line. We know that B is between A and C. And they want us to find 3 pieces of information. Draw a picture. Then they give us some things to help us figure it out. And they say B is the midpoint of AC. Okay? So if I'm drawing a picture, I might make this AC. And they say that B is in between A and C, but they also say that B, and I summarized everything here, B is the midpoint of AC. So if I'm going to guess around right there, and this is not being precise because like technically that does not look like the midpoint, but I know that that's what I meant. Okay. Now let's label what we have. AB is x plus 12. So from here to here is x plus 12. I also know that BC from here to here is 2x minus 3. And where you might be confused is usually they tell us the whole thing. Now they don't tell us the whole thing because by definition, if B is the midpoint, then that means these should be the same. If it's in the middle, then the two segments should be the same. So I could just set x plus 12, and there's a problem. I shouldn't say this on video, but you should definitely know how to do this one. From there, Algebra 1 skills. Let's see. I like the x's on the left, so I might go minus 2x. It's negative 1x. And then from there, I might move the 12 over. From there, divide by negative 1. And I get x is 15. They don't care about x. Never once did they ask for x. But we needed to find x to answer the question. And so I know x is 15. So let's plug in. AB would be 15 plus 12, 27. BC would be 2 times 15, 30, minus 3, 27. And then what would the whole thing be if they're both 27? That'd be 54. Done. See how I got that? Alright, finally, number 12. This is coordinate geometry. And so if you place points on a coordinate plane, you could find the midpoint. You could also find the distance. I believe this is for honors geometry, so if you don't know how to do number 13, you'll be fine.